Let's start working on question 2 now. So we have a linear function f of x with a positive slope. So this is the function s times x. We can see it on this graph over here. We have an area underneath the line, which is a triangle. Now, what do we have? The triangle has a basis of length b. So this is our length b. And it also has a height equals to s times b. So this is the height of the triangle, and that's equal to s times b. Okay, now the area of a triangle is equal to 1 over 2 times hb. In part A, we have to compute the area using an integral and prove that it is indeed 1 over 2 hb. So how do we do that? We know that integrals are used to compute areas, so we're going to calculate the area underneath this line, right? The integral of the function between 0 and b. So those are the boundaries of the integral. We're calculating the area of a definite integral between 0 and b of the function f of x. So we will have s times x times dx. S times x times dx. What do we know about s? S is the slope. S is a constant. So we can take it outside, and we will have s multiplied with the definite integral between 0 to b of x times dx. Now, what is the integral of x times dx? Well, that's the power rule of integral. That's going to be x to the power of 1 plus 1, which is 2, divided by 2. Now, what do we do next? Well, we can take one more constant out, because x to the power of 2 divided by 2, that's going to be equal to 1 over 2 times x squared. So we can take the 1 over 2 outside this expression. So we will have left s multiplied with 1 over 2. And over here, we're left with the boundary between 0 to b of, what was it? X squared. So we're left with x squared. Now we can use the substitution of these boundaries into this result of the integral. So we substitute b over there, and we're going to have s divided by 2 times b squared. So we're left with b squared, and we substitute 0 as well, minus 0 squared. Now what's that going to be? Well, that's equal to s times b squared divided by 2. The 0 has no influence over here. What is s times b squared? Well, that's equal to s times b divided by 2. What else do we know? S times b is equal to the height. The height is equal to s times b, so we're going to substitute that with the height. S times b over here is our height. So as a result, we're left with h, the height, times b divided by 2. Did we prove that we wanted the area to be this way? Well, the area should be 1 over 2 h times b, which is what we just did. So yes, we proved it, and we are done.